Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at 2.4, solving systems of equations, but now we're looking at it graphically. We've done substitution, we've done elimination in past videos. You can watch those if you still need to. But today we're going to be graphing to find solutions. If you need to graph these by hand, we're not going to be doing that. We're going to be using Desmos. So if you need to do it by hand, you might need to find a different video. But today we're going to be mainly focusing our conversation on what is a solution graphically and what are different types of solutions that may occur. Let's look at that first equation on the left, the one that's in that purple box there. Let's type that into Desmos and see what that actually looks like. When you do so, you get these two lines, right? That's the first and the second equation we saw. I'm going to choose a coordinate on one of these lines and just start talking about what these coordinates on lines actually represent. That first coordinate that you saw me click, that was 17, 0. That means the x value is 17. So what I'm going to look at is what happens if I replace the x and the y. So the x was 17, the y was 0. Notice that gives me a value of 17. That's what our equation was equal to. Anytime I have a coordinate on this line, it should give me an x and a y value that make this equation equal to 0. Okay, that is for the blue equation that I'm looking at right now. Let's look at another coordinate. I think there's a coordinate over here at negative 10 and 9. So let's replace the 10 with negative 10. Sorry, let's replace the x with negative 10 and the y with 9. Notice that does, again, give us 17. So what that's telling me is any coordinate on your line is a solution. So if I need a solution to a system, I need a spot where the lines are the same. It needs to satisfy both equations. Well, the only time your two lines are the same is when they're crossing each other at this coordinate 2, 5. Well, what that tells you is anytime your lines cross, anytime they intersect, that is the solution to the system. So what we just saw is we have two lines looking something like this. Where they cross is the solution. And the solution in this case was 2, 5. That is an x and a y value. Let's look at the second case now. The second case, if I type that one into Desmos, let's look here. I've got them already typed in for us. We get something like this. Well, notice if you zoom out, these lines never touch. They never get closer. They never get further. These are parallel lines. Well, parallel lines, I need them to cross to have a solution, right? A solution is where they're the same. But these two lines are never the same. They never cross. Well, when you have parallel lines, what that means is you get no solution. You will never find an x and a y value that satisfy both of your equations. Last example then, third one, we type that into Desmos. We see what those two lines look like. Here's my black line, here's my red line for the two of them. But wait, I only see one equation now, right? When I type in both of these, the red line got rid of the black one. In other words, it covered it up. They're overlapping lines. These lines are the exact same. No matter where you are on this line, they have the same values. So what that tells me is when you have overlapping lines, they're the same everywhere. Well, if they're the same everywhere, that means they're intersecting everywhere. Overlapping lines is what we're looking at. If they overlap, they intersect everywhere, that means there's a solution everywhere. That means you have an infinite amount of solutions. Those are the three cases you can get when you're solving linear systems. Again, this was graphing in order to do that. That is our 2.4 video. Thanks for watching.